Since the dawn of humanity, people all over the planet have looked up and wondered, what is up there? Where did it come from? They observed the cycles of the sun and the moon, the return of summer after a long winter, and realized that within this stellar complexity, there is simplicity, patterns that can teach us about life here on Earth. They also observed unexpected events in the cosmos, such as an exploding star. The sky has inspired individuals and civilizations to use untold resources to unravel its mysteries. As each new culture observed deeper into space, they looked further back into time and brought us closer to the origins of life and of the universe itself. Who were these stargazers who sought the truth? These cosmic explorers who dedicated their lives in creating celestial observatories, building castles to the sky. Around 3000 BC, on the plains of Salisbury, England, construction began on one of the earliest and best-known observatories. A circular ditch, roughly the diameter of a football field, surrounded chalk banks, about the height of a man. There was a ring of 56 holes filled with chalk, some wooden posts, and a few standing stones. From the center of the ring, the sun would be seen rising over the Hillstone on the day of midsummer, the summer solstice. The rising point of the moon changes nightly, following a pattern that repeats in an 18-and-a-half-year cycle. At the summer solstice, the northerly progression of the moon reverses over the wooden posts. By about 1600 BC, the sandstone ring and the trilithons recognized today were in place. The narrow spaces within these trilithons align with the gaps in the outer stone circle, pointing to the rising and setting positions of the sun at the summer and winter solstices. They also mark the extreme positions of moonrise and moonset during its cycle. We don't know who built Stonehenge or why. Its alignment implies that Stonehenge was constructed as a temple to the moon and the sun, and it served as an astronomical calculator. But because it was built long before any written records were made, and the structure has decayed and been altered over time, there are many questions that we will never be able to answer. We do know that Stonehenge was only the beginning in our quest for an understanding of our universe. One of the most energetic, explosive events known is a supernova. They occur at the end of a giant star's life, when its nuclear fuel, which provides heat and light, is exhausted. In 1054, an exploding star was visible on Earth over 6,000 years after it actually occurred. It was a spectacular sight for the ancients all over the world. The Chinese recorded that the supernova was visible during daylight for 23 days and visible at night for more than a year. Anasazi astronomers of Chaco Canyon, in what is now New Mexico, looked in amazement at the bright light in the daytime sky and its rising next to the thin crescent moon the next morning. Their record of the event is seen on the underside of a rock shelf, indicated by a large star, a crescent moon, and a handprint. The handprint marks the site as sacred and is used as a guide. Every 18.5 years, when the moon returns to the same position as on that morning in 1054, the fingers of the sacred hand show the location of the supernova relative to the moon. Though the supernova has faded, modern telescopes can see its remnants, the Crab Nebula. The Anasazi residents of Chaco Canyon were observant of the yearly movements of the sun and moon, marking the changing rise and set points of both, with their architecture and with a unique structure called the Sun Dagger. High on a mesa overlooking the canyon, 3 large slabs of rock focus the noontime sunlight into a spiral petroglyph of 19 rings. On the summer solstice, the longest day of the year, a dagger of light intersects the spiral's midpoint. The winter solstice is marked with 2 bands of light. The same 19 rings closely mark the extreme heights of the full moon during its lunar cycle, the same cycle marked by the wooden posts and gaps in the stone ring at Stonehenge. The shadow of the slabs caused by the moon's light pass from the midpoint of the spiral to the edge and back again to the center over that 18.5-year period. The rudiments of astronomy exist in all cultures and give expression to the belief that all life results from the union of earth, water, and sun. Astronomy is the knowledge that creates an orderly scheme of things and guides us through the cycle of the seasons. And then, in stirring the imagination to look beyond our earthly boundaries, to forge our personal bond with the cosmos. The greatest observatory of the 16th century arose from the imagination of a colorful Dane, Tycho Brahe, and his patron king, Frederick II. Kidnapped by his childless aunt and uncle, Tycho studied astronomy in secret. At 17, he observed a conjunction of Jupiter and Saturn, an event when 2 celestial objects appear very close together in the sky. But when he noticed that the predictions were wrong in time and place, he began his search to create the most precise instruments to learn the truth. One of his earliest efforts was a monstrous oak and brass quadrant, hoping to achieve minute of arc accuracy, but it was heavy and cumbersome. A competitive man, Tycho lost part of his nose in a duel with his cousin over who was the better mathematician. As his nose was healing, the heavens provided him a rare gift, a solar eclipse. Later, while staying with an uncle, Tycho spied an extremely brilliant new star, a supernova in the constellation Cassiopeia. His measurements showed no parallax, no apparent movement against the background of stars, proving it was in the realm of the stars, far beyond the moon. Tycho realized that Aristotle's philosophy of an unchanging cosmos was wrong. Tycho's booklet, De Stella Nova, The New Star, made him the most prominent astronomer of his time. King Frederick II of Denmark gave Tycho the 2,000-acre island of Hven and the means to build the most elaborate observatory in existence. For 20 years, he was Lord of Uraniborg on Hven, where he precisely determined positions of 777 stars, carefully recorded the motions of the sun, moon, and planets, proved that comets were far from Earth, and measured the length of the year to within 3 seconds. The mural quadrant was one of his 4 favorite instruments. For the other 3, he built Stellaborg beneath the frost line, with the first rotating roofs to protect the instruments and their observers. Soon after the death of King Frederick, Tycho lost his influence and his island. Within 20 years of his departure in 1597, the observatory was gone. Appropriately inscribed over one of the doors of Uraniborg was, "Neither wealth nor power, but only knowledge alone endures." And so, just a few years later, Johannes Kepler, using Tycho's measurements, learned that the planets travel in ellipses, with the sun at one focus. The Earth was no longer the center of the universe. Newton could derive his laws of motion and gravitation, and orbits could be predicted, not only for comets, but for satellites and spacecraft to the moon and beyond. The first person to use a telescope for astronomical observation was the Italian Galileo Galilei. Through his small, handmade refractors, he observed that the moon had craters and mountains, demonstrating that the moon was not an unblemished crystalline sphere as previously believed. He also observed 4 satellites orbiting Jupiter, challenging the belief that all bodies orbited the Earth. Galileo became convinced that the planets moved around the sun, the view that Copernicus had written about almost 100 years earlier. Now Galileo was challenging the authority of the Roman Catholic Church, whose interpretations of the Scriptures held that the Earth was stationary. The greatest scientist of his time was summoned before the Inquisition in Rome, where he was condemned as vehemently suspected of heresy and forced to retract his opinions of a Copernican, sun-centered universe. However, the Church was quietly building solar observatories, and for one very simple reason. In 325 AD, the Council of Nicaea decreed that Easter be celebrated on the first Sunday after the first full moon, after the vernal equinox, the day spring arrives as the earth is tilted so that the sun is directly over the equator and the hours of light and darkness are equal. Calculations of Easter were not easy and were complicated by the inexact Julian calendar. As a result, solar observatories were installed in cathedrals throughout Europe. A small hole in the roof allowed a beam of sunlight to strike the floor. On each sunny day, the solar image would sweep across the church floor and exactly at solar noon cross the meridian line, a path that runs from north to south. The noon crossings over the course of a year would reach the line's extremities, the summer and winter solstices. By counting the number of days, hours, and minutes between appearances of the sun at the same point, the vernal equinox could be determined, thus providing an unquestionable date for each year's Easter, reinforcing the Church's unity and power. The solar observatories would indirectly prove the ideas condemned at the trial of Galileo to be correct. In 1992, the Church finally admitted it erred, but by the 18th century, the solar observatories began to lose their astronomical value because of another legacy of Galileo, the development of the modern telescope. The next great observatory had modest beginnings in the basement of the home of William Herschel, an organist in Bath, England, and his little sister, Caroline. Telescopes were small, rare, and expensive in the 18th century, so William resolved to make his own with Caroline's help. William finished his first small 6-foot reflecting telescope in 1774, and later succeeded in creating a 20-foot telescope with an 18.5-inch mirror, all while still earning a living as a musician. The Herschels observed at every possible moment. Caroline noted that if it were not for the intervention of a cloudy or moonlit night, they would have never gotten any sleep. Herschel's dream was to map the universe in 3 dimensions. Each night he would sweep the sky along adjacent paths, memorizing it like a sheet of music. In 1781, sweeping the sky with a 7-foot reflector with a small mirror of his own making, he noticed a pale green star misplaced in the constellation Gemini, which he imagined to be a comet. Herschel the musician had discovered Uranus, the first new planet since prehistoric times. King George III, glad for good news after losing his colonies in the American Revolution, made Herschel his personal astronomer and gave him £4,000 to supervise the construction of the largest telescope in the world. The 4-foot metal mirror weighed a ton, and its wooden tube stood 4 stories tall. At its dedication in 1789, the king took the arm of the Archbishop of Canterbury, saying, "Come, my Lord Bishop, I will show you the way to heaven." With this new machine, Herschel could survey the sky, see the moons of distant planets, and beyond to star clusters and over 2,000 nebulae. He recognized that the sun was a star, and that stars were moving throughout a comparatively thin but immense Milky Way. He imagined that the universe had been formed from the nebulous clouds he saw outside the plane of the Milky Way. Over a century would pass before an even larger telescope in California would prove what Herschel imagined to be the whole universe was but a single galaxy in a universe of billions of galaxies. In 1914, a 24-year-old high school teacher in New Albany, Indiana, posed for a photograph with one of the world's smallest telescopes. In less than 10 years, Edwin Hubble would hold in his hands a photographic plate fresh from the world's largest telescope that would show for the first time individual stars in another galaxy. On an October night in 1923, Hubble used the 100-inch diameter Hooker telescope at Mount Wilson to take a photograph of the Andromeda Nebula. This telescope was the largest built at the time, using a glass mirror with a silver coating. On the photographic plate, he identified one of the bright pulsating stars that we call Cepheid variables. These had been seen before in our own galaxy and in the Magellanic Clouds. He knew how bright this variable should appear if it were nearby, but it was extremely faint. From its apparent brightness, he deduced that the star was well beyond our own galaxy. The Andromeda Nebula was not a nearby nebula at all, but a galaxy much like our own Milky Way, over 2 million light-years away. Milton Humason, a former watermelon farmer and mule driver who hauled parts for the telescope up the mountain, had become one of the most skilled observers with the 100-inch telescope. With a new efficient spectrograph that could analyze the light from a galaxy to determine its speed, he measured the velocities of the galaxies for which Hubble found distances. In 1931, they jointly announced their discovery. The more distant a galaxy, the faster it was moving away from us. They had discovered the expanding universe, predicted by Einstein's theory of general relativity. Our atmosphere prevents dangerous radiation from reaching the surface of the Earth, but it is through this filter of nitrogen, oxygen, carbon, and other elements that we must look to get to the heavens. Rockets and space shuttles have allowed astronomers to move telescopes above the atmosphere, transporting observatories into space. This unrestricted view gives us the opportunity to learn even more about how our universe has evolved. A satellite called the Cosmic Background Explorer, or COBE, explored the cosmic background microwave radiation, the remnant light from the Big Bang, giving further support to models of the origin of the universe. COBE found small areas of temperature fluctuations, thought to be the seeds for the formation of galaxies billions of years ago. A recent initiative by NASA and others, called the Great Observatories, is a collection of 4 orbiting telescopes designed to study the universe in both visible light and other forms of radiation. The Compton Gamma Ray Observatory was launched into Earth's orbit from Space Shuttle Atlantis in 1991. Gamma rays are produced by violent events, such as supernovas, black holes, and even solar flares from our own star, the Sun. Compton data helped astronomers understand how black holes trigger massive jets that streak outward at nearly the speed of light. Launched in 1999 from the Space Shuttle Columbia, the Chandra X-ray Observatory was designed to give astronomers unprecedented images and spectra. X-rays are generated in violent high-temperature events, from the heart of quasars to the accretion disks around black holes to the hot gases stirred up in the intergalactic region within clusters of galaxies. Because of their higher energies, the X-ray emission gives us amazing views at objects like the Crab Nebula. The view from Chandra reveals that high-energy X-rays are concentrated toward the center of the nebula, where a rapidly spinning neutron star, or pulsar, emits pulses of radiation 30 times a second. Spectacular ring-like structures around the central pulsar are visible, as are jets blasting away from the pulsar. 1,000 years after its initial explosion, the Crab Nebula continues to evolve. NASA plans to launch the Space Infrared Telescope facility in April of 2003. It is designed to look at cool objects from planets to microscopic dust particles. Because the dust can block visible light, studies in the infrared provide a tool for probing through this dust deeper into the nursery where stars and planets form.
Liftoff. Liftoff. 30 minutes after the hour.
But the best known of the great observatories is the Hubble Space Telescope. Deployed in 1990 and named after Edwin Hubble, this Earth-orbiting telescope marked the beginning of an exciting new era in astronomy. The Hubble has provided views of objects within our universe, unparalleled to date in both their resolution and their beauty. From the planets within our solar system, to the birth and death of stars, and on to the farthest galaxies within its reach, the Hubble Space Telescope has unraveled age-old mysteries and forced astronomers to once again rethink long-held beliefs. As each celestial observatory was built, whether Stonehenge, Uraniborg, or the Hubble, the discoveries revealed new mysteries as they led us deeper in space and time, raising as many questions as they answered. The Hubble Space Telescope reveals primitive galaxies forming from hydrogen and helium atoms left by the Big Bang. Even beyond that, telescopes sensitive to infrared and microwaves show us the slight ripples through the hot gases of the primitive universe. We are probing the very origins of the universe and the origins of ourselves, as observatories have done for over 5,000 years. A telescope to replace the Hubble Space Telescope is being developed to provide clearer pictures of the early universe, planets around other stars, and the very beginnings of time. Our quest continues, and Castles to the Sky will lead the way.